Good morning, students. Today we are going to read in the subject of chemistry, paper number 4, that is called Alternate to Practical. And in short, this is called ATP chemistry paper. That is actually paper number 4 of chemistry subject. And our today's topic is identification of the ions and gases. And in this topic, we are going to read today, that is identification of the cations. So concentrate yourself. This is purely a topic of paper number 4. So a lot more concepts and ideas are going to be involved in this topic. This is somewhat tough topic. So you have to concentrate. We are going to start now. So look here. Identification of the cations. Aqueous cations are identified by using alkalis such as aqueous sodium hydroxide and aqueous ammonia. So the first thing is aqueous cations can be identified by using sodium hydroxide and ammonia. So look now, most cations combine with hydroxide ion to form insoluble metal hydroxide. And this is the general equation. And here are the equations. So when Mg2 plus, so metal ion, when react with hydroxide ion, that is OH negative ion, it makes the metal hydroxide, that is MgOH twice. So this is white precipitate. When copper ion react with hydroxide and ion forms copper hydroxide, that is blue precipitate. When iron, that is Fe2 plus, ion react with hydroxide ion, it forms iron hydroxide, that is FeOH2, that is green precipitate. And when Fe3 plus react with hydroxide ion, it forms FeOH3, that is brown precipitate. Figure below summarizes the reactions of the cation with the aqueous sodium hydroxide. So concentrate, this is the figure which will make all your concepts clear, how we will identify the cation. So look now, here is the a little NaOH, that is aqueous. So when aqueous NaOH will react with the metal ion, if no precipitate is formed, then on heating, colorless gas turns litmus blue, dense white fumes formed. So look now again, if the metal ion reacts with the aqueous NaOH and no precipitate is formed, this is the first sign. Then on further heating, if a colorless gas is formed, so you will feel a gas that will be a colorless. And if you put the red litmus into it and if it turns into blue, and the dense white fumes formed with the concentrated ACl, then with it will be NH3, that is ammonium ion will be there. And if the metal ion react with aqueous NaOH and some precipitate is formed, you feel that the precipitates are formed. And if the precipitates are of white color, then further heating, further reacting with excess NaOH, if it is insoluble, then that will be calcium ion. And if reacting the metal ion with the aqueous NaOH, some precipitate is formed and the precipitate is of white color, then further reacting with excess NaOH, if it dissolves and colorless solution is formed, then it will be either aluminium ion or the zinc ion. Further again, come back. So if the metal ion react with the aqueous NaOH and a precipitate is formed and the precipitate is colored, and if the color is blue, that will be Cu2 plus ion, cation. And if the color is green, that will be Fe2 plus. And if the color of the precipitate is brown, that will be Fe3 plus. So you have to learn this figure, these concepts. Okay, cations such as Pb2 plus and Al3 plus and Zn2 plus form insoluble metal hydroxide that dissolves in the excess aqueous sodium hydroxide to form colorless complex ions. So this is actually the original figure. This is just the explanation. So you have to learn these concepts which are given in the figure. Pb2 plus and Al3 plus can be distinguished by using aqueous potassium iodide. Pb2 plus ions combine with I minus ions to form an insoluble yellow precipitate of lead iodide, that is Pb2 plus plus 2I minus forms lead iodide, that will be of yellow color precipitate. Figure below summarizes the reactions of the lead and aluminium ions with potassium iodide. So this is another figure which you have to learn. So look now, when the reaction of the lead and aluminium with the potassium iodide. So lead and aluminium. So look now, when reacting with the aqueous Ki, if no precipitate is formed, that will be Al3 plus ion. And if reacting with aqueous Ki, yellow precipitate is formed, then that will be Pb2 plus. So this is another figure that you have to learn. Figure below summarizes the reaction of the cation with the aqueous ammonia. So this is another figure whose explanation will be given further. So this is the original thing actually. So this is the third figure which you have to learn. First figure, that was the NaOH, the starting point. Then the Ki was the starting point, and now the NH3 is the starting point. So look now, figure below summarizes the reaction of the cations with aqueous ammonia. So if the cation react with ammonia and if no precipitate is formed, so again concentrate, now the cation is going to be reacted with the NH3. In the first figure, cation was reacted with the NaOH. In second figure, the cation was reacted with Ki, and now the cation is going to be reacted with NH3. So these are three different tests. So that will determine which one is the cation. So if the cation react with the aqueous NH3 and if no precipitate is formed, then ammonia or calcium ion will be the cations. And if the cation react with aqueous ammonia and a precipitate is formed, and if the precipitate is of the white color, and on further reacting with excess NH3, if it is insoluble mean it will not be soluble, so then aluminium ion will be there. And if it dissolve and colorless solution is formed, it will be zinc cation. And if the cation react with the aqueous ammonia and if a precipitate is formed of the colored precipitate is formed, if the color will be green, that will be Fe2 plus. If the brown color is brown precipitate is formed, that will be Fe3 plus. And if the blue color precipitate is formed, then that will be Cu2 plus. Okay, now we will decide which one is this one, because actually there are three options in the color precipitate. So if further reacting with excess NH3, if it is insoluble, then that will be Fe2 plus and Fe3 plus. So there will be either of these two. And if it dissolves and dark blue solution is formed, that will be Cu2 plus. So this is the original figure again. So I'm telling you again, you have to learn these three figures. So I'm going to show you again these three figures. This is the first figure. If the cation react with the aqueous NaOH, and if these three, so these are the signs to determine which is the cation. So here is the second figure now. If the cation react with aqueous Ki, and this figure is having a very limited scope for only aluminium and lead. And this is the third figure which you have to learn. That is, if the cation react with ammonia, these will be the signs to determine which is the cation. Here is the explanation. Actually, that is actually from this figure again. So zinc ions form a white precipitate with aqueous ammonia, which will then dissolve excess ammonia to form colorless complex ions Copper ions form a blue precipitate with aqueous ammonia, which then dissolve in excess ammonia to form deep blue complex ions. So this was the topic to determine the cations. So this was the topic for today. That was determining the cations. So I hope so this will be much more interesting and easy for you to understand now. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.